Okay, so welcome to the 7th video for section 8.4. So let's note, we know that sine of theta and cosine of theta are bound between -1 and 1 on the unit circle. So what this means is that they are maximized. The maximum value both sine and cosine can have is 1 at 1. Okay, so if I have sine of theta equal to 1, that implies that the angle theta must be pi over 2. If I have cosine of theta equal to 1, that implies that the angle theta must be equal to 0 radians. Okay, well, let's consider something. Consider sine of n theta equal to 1. So what that means then is that the angle n theta is pi over 2. Dividing both sides by n, that gives us that theta is pi over 2n. And similarly for cosine of n theta equal to 1, well, what that gives us then is that n theta in this case must be 0. Dividing both sides by n, I get that theta is 0. Okay, so hopefully that makes sense. So that's the maximum value for both. So max for sine is at pi over 2n, and the max for cosine is at 0. Okay, so given that, let's consider the definition of a rose. So definition. So we have a rose is a polar graph given by, so is a polar graph given by given by either r is equal to a times sine of n theta, and this would be, how do I want to say this? First along theta equals to pi over 2n. And in the second case, we have r is equal to a cosine of n theta. And once again, I'll say first. So what do I mean by first? I'll get to that in a moment. Along theta equals to 0 radians. Okay, so where we have the following. So A is the petal length. And let's do petal spacing. No, actually, let's do n first. So number of petals. N is going to be either n if n is odd, or 2n if n is even. Okay, then next we have the petal spacing. Well, you have the number of petals divided evenly into 2 pi radians, so 2 pi divided by n. Okay, and each of these is through the pole. So through pole. Okay, so let's see what we mean by this. Okay, so for example, So let's plot the following roses. Following roses in the polar plane. Okay, so number 1, let's say we have that r is equal to 2 times cosine of 3 theta. Okay, so what is A in this case? A, the petal length, is 2, and that's the length. Little n, the coefficient of theta, is 3. So that means because it's odd, capital N, the number of petals, is also 3. So the spacing is going to be 2 pi divided by the number of petals, 3. Okay. And since this is cosine, the first petal, so the first petal for cosine is along theta equals to 0 radians. Okay, so let's go ahead and plot this. So x and y coordinate axes. I know I have to go out to a petal length of 3. That means that I need to do 3 concentric circles. So x and y. So let's do radius of 1, then a radius of 2, kind of, and then, oh, no, that wasn't a radius of 2, hold on. Okay, and then a radius of 3. Okay, hopefully that looks okay. Okay, and now our angles. We know this is our 45-degree angle here. 45-degree angle here. And let's do our 60-degree angles here. 60-degree angles here. 30-degree angles here. No, that's not a 30-degree angle. That's still not a 30-degree angle. Okay, come on, I can do this. 30 and 30, right? Okay, so assume, if you will, those are the correct angles. Okay, so my first petal of length 2, sorry, it was length 2, is along theta equals to 0. So my first petal is along theta equals to 0. That's the polar axis, positive polar axis. I know I go through the pole. And the spacing is every 2 pi over 3 radians. So here's 2 pi over 3. 2 pi over 3 plus 2 pi over 3 is 4 pi over 3. And then if I were to add another 2 pi over 3, I'd be at 6 pi over 3, otherwise known as 2 pi. So I've gone full circle. So my next petal will have a length of 2 in the direction of 2 pi over 3, and then 4 pi over 3. So when I draw this rose, I have petals of length 2. Oops. Come on, why do I want this erased? Length 2 in every 120 degrees. So they're evenly spaced within 360 degrees. And you know what? That's kind of hard to see. So I'm going to draw it in a darker purple, just so you can see the graph, because the grid behind it, I'll use a different color next time. So here's my first petal, kind of. Then my second petal. And then my third petal. This is called a trefoil. Okay, so hopefully that's easier to see. Like I said, I'll use a lighter color in the next example. Okay, so number 2. Let's see, what do we have for number 2? Let's do r is equal to 5 times cosine of 2 theta. So in this case, the petal length A is 5. The coefficient of theta is 2, so that means because it's even, the number of petals is twice 2, which is 4. So there's 4 petals. So the spacing of those petals is still 2 pi divided by n, so 2 pi over 4, which reduces to pi over 2, which would make sense every 90 degrees. Okay, since this is cosine, I know that my first petal will be along theta equals to 0. Okay, so let's go ahead and plot this polar graph, if I can. Let's see if I can do this correctly this time with a lighter color. Pardon me. Okay, so x and y coordinate axes. Let's use this color. So here's my circle of radius 1. No, it's not. It's not going to do it. Okay, here's my circle of radius 1. There we go. Here's my circle of radius 2. Almost. Kind of. Okay. Now here's my circle of radius 3. Kind of. Did that work? Why is it always just a little bit off? Okay, now my circle of radius 4. And finally, my circle of radius 5. Oh, thank goodness it created a circle. Okay. Okay, so now let's do our angles. Easiest angle, of course, is a 45-degree angle. Just an X through the center. Okay, my 30-degree angles. And now my 60-degree angles. And note, this is probably not drawn correctly, but you get the idea. Okay, so now I know that my first petal is along theta equals to 0, and it has a length of 5. So I go through the pole. My first petal has a length of 5. And then it's every pi over 2 units. So 1 pi over 2, 2 pi over 2, 3 pi over 2s. Okay, so every pi over 2 units, I have a petal of length 5. So I should have 4 petals. My first petal. My second petal. No, not drawn very well, but I'm trying. I'll just go ahead and do this one down here first. 3 and then 4. You'll see when I actually provide you with coded ones, they look much better. Okay, so there we are. Now let's try for sine. Let's do a couple involving sine. So number 3. So let's say we have r is 2 sine of 3 theta. Okay, so once again, the petal length here is 2. The coefficient of theta is 3, which is even. So that means 3 is odd rather. So the number of petals is also just 3. So the petal spacing is going to be 2 pi divided by n, which is 3. So every 120 degrees. However, because this is sine, the first petal will be along theta equals to pi over 2 times n. So for us, that's pi over 2 times 3, so pi over 6. Okay, so let's go ahead and draw the coordinate axes here. We only need to go out to a radius of 2, thank goodness. But I guess doing this builds character, right? Okay, so once again, a radius of 1 and a radius of 2. I guess I didn't need to draw it that big now, did I? Oh well, that's terrible. Okay, I wanted to draw a circle. Let me draw a circle. Let me try and draw a circle. Okay. Okay, so now we have our degrees 45-degree reference angles. Let's do these 60-degree reference angles. And then the 30-degree reference angles. Okay, so my first petal is going to be along pi over 6 at a length of 2. Then I have to go every 120 units. So 120 plus 30, or 2 pi over 3 plus pi over 6, is going to be 5 pi over 6. So 150 degrees plus another, so that's where I have my second petal. If I add another 120 degrees, that's going to be at 3 pi over 2, or 270 degrees. And you'll notice these are evenly spaced, so just make sure they're evenly spaced. So first petal, second petal, and third petal. So it's another trefoil, but it's sine because its first petal is not along the positive cosine like that one was. Okay, so let's do another one. So number 4. So let's say we have r is equal to simply sine of 4 theta. Should I do just sine? No, let's try a number. Let's try number 3. How about that? So now my radius is 3. So my petal length is 3. The coefficient of theta is 4, so that is even. So therefore my number of petals, n, is 2 times 4, or 8. So I have 8 petals now. So the spacing of those 8 petals is going to be 360 degrees divided by into 8. Okay, so that reduces to pi over 4. So every 45 degrees I'll have a petal. And because this is sine, I know my first petal will be along theta equals to pi over twice n, where n in this case was 4. Little n, right? So pi over 8. So pi over 8, that's half of pi over 4, so that's 22.5 degrees. So this will be interesting. So let's go ahead and do x and y coordinate axes. I always seem to get that off. Okay, so we just need 3 circles. 1, almost. I almost got it. No, come on. Okay, first and second circle of radius 2. And then the third circle of radius 3. Kind of. No, but yeah. Okay, let me see if I can do this. I can do this. Radius 3, I can do this. Come on, I can do this. Okay, almost. That's good, that's good. Okay, looks good enough for government work. Okay, so now I'm just going to put my 45-degree angles here. Oops. Because I'm dealing with petals that are every 45 degrees. However, the first petal is at a length of 3 at an angle of pi over 8, which is half. So pi over 8 is half of pi over 4. So here's my first petal. My second petal will be at pi over 4 later, so that's 3 pi over 8. Then my next petal will be halfway between these two guys. So that's, let's see, 2 pi over 8 more, so that's 5 pi over 8. Then I go another 45 degrees, or 2 pi over 8. So that's 7 pi over 8. Then I go another pi over 4, or 2 pi over 8. So that'll be 9 pi over 8. Then I go another 2 pi over 8, so that gives me to 11 pi over 8. Then I go another 2 pi over 8, or 45 degrees, which gets me to 13 pi over 8. Pardon me. Then another 2 pi over 8 gets me to 15 pi over 8. And notice if I were 1 more pi over 8, I'd be at 2 pi. Okay, so here are my petals. So 1, 2, 3, 4, 5, 6. Let's see, 7 and 8. Okay, that's time for government work. Okay, so that one looks pretty. I actually like that one. So let's see, number 5 for good measure. Only because I've done 8 petals, 3 petals, 4 petals, and 3 petals. So I wanted to show you 5 petals because that's kind of my favorite. So let's do r is equals to 4 times cosine of 5 theta, only because cosine is easier to deal with. So my petal length is 4. The coefficient of theta, n, is 5, which is odd. So the number of petals, n, is 5. So the spacing, so this is interesting. What's 360 degrees divided by 5? Well, that happens to be 72 degrees. So we'll keep that in the back of our heads. And because this is cosine, thank goodness, we know that the first petal will be along theta equals to 0 radians. Okay, so now we need to have 4 concentric circles. Oops, wrong color. It's inevitable. I can never do an even number. That's interesting. Okay. So X and Y. And here we go with me doing this. But I'm going to try something new this time. I'm going to copy this and I'm going to paste it. And let's move this to here, and then I'm going to increase the size. Okay, that works. Now let's paste again. Let's move, move this. Oh, it doesn't want to move. Okay, move it to here. And nope, okay. Still doesn't want me. Nope. Okay. Trying to get it right there. Okay. Let's move this to 3 almost. Okay, let's do this again. Paste. Move it to 4. And make it, okay, that is an easier way for me to do it. Okay, now, I actually don't really need the grid, but what the heck, I'll do the grid, the 45s, how about that? Heck, I'll do it all, and I'll show you why. So my 45s, my 60-degree reference angles, and my 30-degree reference angles. Okay, so we know that we always go through the pole, and my first petal is along theta equals to 0. So we've got that down at a radius of 4. But now my first petal is at 72 degrees, which is going to be a little bit beyond the 60, right? My next petal, if I add 72 and 72, I get 144. So that's going to be not quite 150, so 144 degrees is going to be about here. Then if I add another 72 degrees, I get 216. Okay, so if 216 is a little bit beyond 210, so it's going to be about here. Then my next petal, if I add another 72 degrees, that's going to be 288 degrees. Okay, but if I were at 5 pi over 4, sorry, 5 pi over 3, that would be 5 times 60, or 300. So I'm not quite there yet, so I'm just shy of it. Okay, so what I get is 5 petals. The first one along theta equals to 0. Then every 72 degrees, or 2 pi over 5. Oops. Okay. Kind of like roses, they're pretty. Okay, I know that last line wasn't that great. Let me redo that last line. Let's see. Okay, maybe that's a bit better. Okay, so let's see. Should I just leave it there? Yeah, because the next thing is a different subtopic. So I think I'm going to leave it here for this video, and we'll do one more video for chapter 8.4.